Hi, class. We're going to enter a topic that's on different types of muscle fibers, and we're going to focus on um, these slow and fast fibers. Okay, notice some of them are dark, some of them are red, and some of them are white fibers. We have dark and white fibers. Now, um, as we're talking about this, I want you to think about Thanksgiving. And if you celebrate Thanksgiving with a turkey, as many people do, some people have a preference, right? There's always that battle. Oh, I want the dark meat. Oh, I want the white meat. Okay, so meat comes in different colors. You have dark meat and you have white meat. What makes dark meat dark is good blood supply. And what makes white meat white is not a good blood supply. Okay? Keep that in mind. The better the blood supply, the more energy it has, the more it can contract. And the less blood supply, the less oxygen, the less energy. So let's look at fast fibers first. Okay, let's look at these fast fibers. So fast fibers, they're called fast because they contract quickly. They have large diameter, large glycogen reserves, glycogen, stored sugar, but they have few mitochondria. Okay. Blood supply poor. So if the blood supply isn't the best and you have few mitochondria, I think if there's few mitochondria, then there's less ATP. If there's less ATP, then there's going to be less energy for long-term stuff. So fast fibers, they contract quickly. These are good for muscles where you need a very strong contraction. Okay, these are needed for where we have, give me a second, strong contractions, but they fatigue easily. So if you're a power lifter and you're doing a deadlift once, you just need the muscles to contract quickly. You need to have a strong contraction, and you can't do that long. They fatigue pretty quick. On the other hand, we have slow fibers. These are slower to contract, and they're also slower to fatigue. These have more mitochondria. If you have more mitochondria, that's going to result in more ATP. More ATP equals what? More energy. More energy. And good blood supply, good oxygen supply. So now you have good oxygen coming in to the mitochondria of the cell. So that, remember, you've got your glucose, and the glucose is broken down, that 6-carbon sugar is broken down into pyruvic acid. If you got lots of oxygen, now you got pyruvic acid that can enter the mitochondria so that we can make all that ATP, make all that energy. So the slow fibers have a really good blood supply and has this dark red pigment. So that when we look here, this is the slow oxidative fibers. They can last for a long time. They don't fatigue easily, but the fast ones can fatigue easily. So the red muscles, mostly slow fibers. These are the dark ones. Think of turkey. Think of chicken. During Thanksgiving time, that debate between dark meat and white meat. If you want the dark meat, you're going to have the leg. If you want the white meat, you're going to go with the breast. Because birds like turkeys are not flapping their wings and flying in the air. If they were, then that would have great blood supply. Those turkeys are getting around through their legs, not the pectoralis muscle. So the pec muscle in the breast is the white meat that looks pale. And the red muscle, the legs, that's going to appear dark. Humans, we have a combination of both, right? Some people may have more white fibers, those are your power lifters. Some people have more red fibers, those are your marathon runners. Okay, but we have like pink fibers. There's a combination of both. Now, the fast fibers, these are the ones that fatigue easily. Those are the muscles of the eye. That's why when you read at night, you get tired because they fatigue easily. Whereas you have leg muscles and calf muscles and lower back muscles that are your postural muscles, and you could stand for hours on end. Okay, that's because they're made up of slow fibers. They don't fatigue easily. They're more fatigue resistant. Okay, when we come back, we'll finish on hypertrophy and atrophy of muscle.